Hello. In this video, we're going to look at some advanced homework problems from combination circuits. Alright, so the first couple problems that we're going to do are going to involve finding the total resistance. So let's start off here. Let's say that we have a battery, and then we have some resistors like this. And then we have another resistor down here. And we have another resistor here. So for these problems, our goal is always going to be to get rid of the parallel parts. So when we look at the problem, the things that we're going to be looking for are things that are in parallel, so we can remove or simplify down the parallel parts. So let's say that we have some values here. So let's say that this is R1, R2, R3, R4, R5, and R6. And let's say we have 100 ohm, 200, 300, 400, 500, and 600. So this would be the resistance of each of these resistors. Okay, so the first thing that we'll do is identify the parts that are in parallel. So this part here is in parallel for this circuit, these three resistors. And so what we're going to do is we're going to simplify those down to this resistor, which I'm going to call RA. So RA is equal to the parallel combination of 3, 4, and 5. So this is going to be R3 to the negative 1 plus R4 to the negative 1 plus R5 to the negative 1. And so if we look here, this would be 400 to the negative 1 plus 500 to the negative 1 plus 600 to the negative 1, all to the negative 1. So let me punch that into my calculator. We'll figure out what the parallel resistance of those is. And for that, I get that this resistor is 162 ohms. So now, what I would do is redraw the circuit and leave the stuff in the circuit that's already there. So this R1 is 100 ohms, R2 is 200 ohms. And my goal is to turn this into a series circuit. Once it's in a series circuit form, then I can solve for the total resistance. Okay, and then here RA is equal to 162. And so if I look here, I now can find the total resistance. It's going to equal R1 plus R2 plus RA plus R6. So my series circuit here, and I would have 100 plus 200 plus 162 plus 300. So my total resistance for this circuit, R total, is going to equal, so I'll put that in my calculator, 100 plus 200 plus 162 plus 300, and I get 762 ohms for the total resistance for this problem. So if we look, our goal is to get rid of the parallel part, so we find what's in parallel, we simplify that down, and then we turn the problem into a series circuit. Alright, let's look at another example. This one will add a couple more things. Alright, so this one will start off with a resistor up here, and then we'll put two resistors here. and we'll have a power supply here. We're not worried about the power supply for this one. We're just trying to determine the total resistance for this problem. So we kind of got a little bit farther on this one. So let's see here. So we have R1, R2, R3, R4, R5, R6, R7, and R8. Let's make this one 500 ohms, 300 ohms, 400 ohms, 600 ohms, 1K, 2K, we'll do 700 for this, and let's make this 1.5K. Alright, so we have 8 resistors here, and we're going to do this problem in a couple steps. So the first thing that we're going to do is try to simplify it down. So we're going to start with things that are in series that we need to simplify first. So here, these two are in series. And also, these two over here are in series. And then this step, there's not anything else that I want to combine in parallel, so we're going to start with those. Alright, so the first one we'll do in purple. Let's call this one RA, and RA is going to be the series combination of R2 and R3, so that's going to be R2 plus R3. So RA is going to equal 300 plus 400, so that's going to equal 700 ohms. Okay, so then I'll put the rest of the stuff on here because that's not changed. This is R1. The power supply is here. Oops. This is still R5, which is 1K. This is R4, which is 600 ohms. All right. Now the next one that we're going to look at is this one. I'm going to call this resistor RB, which is the green one, which is the series combination of 6 plus 7. So that's 2K plus 700. So RB is going to be 2.7 K ohms. All right, so now what we can do is we can put that resistor here, RB, and then we'll put the other resistors here. And so this is still R8, which is 1.5K. And then RB we decided was 2.7K. All right, so now we simplified the circuit down a little bit. And now let's look at what is in parallel. So here, now, we have these 3 resistors which are in parallel. And we have these 2 resistors here which are in parallel. Oh, just a second, it looks like I forgot to, this is a 500 ohm resistor. So I have a 500 and 700 in parallel, and then I have these here. Alright, so let's go over here. I'm going to call this resistor, when I replace these two, this is parallel. So I'm going to put this resistor here. I'm going to call this one RY. And RY is equal to R1 and RA in parallel. So that's going to be R1 to the negative 1 plus RA to the negative 1. So that's equal to 500 to the negative 1 plus 700 to the negative 1 all to the negative 1. So let me punch that into my calculator. And for that, I get RY equals, let me move this out of the way, 291 ohms. All right, so let's put that resistor here. This is going to be RY, which is 291 ohms. The next one that we're going to look at is this one. So I'm going to call this resistor, when I combine those together, RZ. And RZ is going to equal the parallel combination of 5B and 8. So this one's going to be RZ. So that's going to be R5 to the negative 1 plus RB to the negative 1 plus R8 to the negative 1. So RZ is equal to, we'd have 1K to the negative 1 plus 2.7K plus 1.5K to the negative 1. Looks like I ran out of space there a little bit. All right, so let me punch that in my calculator. So I'd have 1K to the negative 1 plus 2.7 to the negative 1 plus 1.5 to the negative 1, all of the negative 1. And for this one, I get 491 ohms. All right, and then lastly, I'll put in this one, which would be R4, which was 600. Okay, so the last thing that we'll do is we'll do the total resistance, which is going to equal RY plus RZ plus R4. So that's going to be 291 plus 491 plus 600. Oops. And that's going to equal 1.38 K ohms. So this would be the total resistance. So if we look at our steps here, we started off with this very complicated circuit. And so we started off by finding the series parts. So we combined R2 and R3. Then we combined R6 and R7. Then we looked at this circuit, which was a little bit simpler, and we found the parallel parts, and we got rid of those and turned it into a series circuit. All right, let's do one more in this arena. So let's say that we have a circuit that looks like this. All right, so this is going to be R1, R2, R3, R4, R5, and for this one, let's say that we have a voltage supply. So we have 60 volts, and we're going to find the voltage and current for each of the resistors. So this is 100, 200, let's do 600, 400, and 150. Okay, so for this circuit, we're going to try to find the voltage and current for all of the components. So we're going to start off first by making a table. All right, and we'll go ahead and put in what we know. So we have voltage, current, resistance, power, R1, R2, R3, R4, R5. Looks like I need to make this a little bit bigger. Okay, and then we'll have the total on the bottom. And then let's first start off by putting in what we know. So we know that this is 100, this is 200, R3 is 600, R4 is 400, and this is 150, and the total voltage is 60. All right, so let's start off here. Now that we have our first table, so we've got to figure out what's in series and what's in parallel. So for this one, these ones here are parallel. So that means that their voltage is the same. So on here, we'll circle this for parallel. And then the next one we'll look at is series. So what's in series? Well, if we look, all of these resistors are in series. So R1, R2, the total, and R5 are all in series. So that means that their currents will all be the same. So I'm going to circle the currents on here. All right, so the first step that we're going to do is we're going to replace the parallel parts. We're going to get rid of those. And then we'll redraw the circuit. So this is R1, R2, 100, and 200. And then this is R5, which is 150. This is 60 volts, excuse me, not ohms. These would all be ohms, ohms, and ohms. All right. And then let's start off by finding this resistor. We'll call this one RA. So RA is the parallel combination of the 600 and the, try that again. So RA is the parallel combination of the 600 and the 400. So 3 and 4. So that's going to be 240 ohms. So that'd be 240 ohms. All right, so next what we're going to do is let's make another table for this circuit. So we'll do that one over here. All right, and let's start off that one by putting in what we know. So we have voltage, current, resistance. This would be R1, R2, RA, R5, and then total. Looks like I need to give myself a little bit more room here. All right, so there's my second table, a little sloppy. This one would be 100. This would be 200. This is 240, 150, and 60. All right. Now for this problem, before we get started on the math part, we need to know that the voltage here for RA, that's the voltage that's going to be used for 3 and 4. So that's the same there. And because we've turned this into a series circuit, this is now the current. Okay. All right. So first step, let's find our total. So our total is going to be equal to the series circuit. So we're going to add them up: 100 plus 200 plus 240 plus 150. So our total equals, let's punch that in our calculators, 100 plus 200 plus 240 plus 150, and that's going to equal 690. Okay. The next thing that we'll do is find the total current. So I total is V total over R total. So that's going to be 60 divided by 690. And that's going to be, if I round it here, it's going to be 87 milliamps. So 87 milli, 87 milli, 87 milli, 87 milli, 87 milli. All right. And so next, what I'm going to do is find the voltages here. So V1 is going to be 87 milli times 100. And that's going to be 8.7 volts. V2 is 87 milli times 200. And that's going to be, darn it, 17.4. V3 is 87 milli times 240. And that's going to be, I'm going to round it up to 21. Let's do 20.9. And then V4 is 87 milli times 150. And that's going to be 13.1. Okay, so let me add those up and see if it makes sense. And it looks good. Okay. So the last one here was 13.1 volts. So then I added them up to make sure that they equal 60, and it looks like they do. We'll double check those in a minute. All right, so now let's transfer up our known quantities here. So this is 8.7, 17.4, 20.9, 20.9, 13.1. The total comes from the bottom, so for the resistance that would be 690. And then we'll transfer up the currents. This is 87 milli, 87 milli, 87 milli. Okay, and then now let's go and we'll do the currents for I3, and I3 is going to be V3 over R3, so that's going to be 20.9 divided by 600. And that looks like that's going to be 30. So I3 is 34.8 milliamps. 34.8. Let's just round it up to 35 so I can fit it on here better. 35 milliamps. And then we'll do I4, which is going to be 20.9 divided by 400. And we're going to say that that's 52 milliamps. All right. And then what I'm going to do next is let's get out an Excel spreadsheet and we'll try to do this problem using Excel. So here I have my spreadsheet. Voltage, current, resistance, power. And then I have R1, R2, R3, R4, R5, total. Let's make this a little bit bigger here. We'll do this. make these centered. We'll make these like that. And then for this one, this becomes our A. We'll delete this. And we'll delete this. Okay, so here are my tables. So R1 through 5, and then R1, R2, RA, and R5. All right, so let's start off by putting in what we know. So we have 100, 200, 600, 400, 150, and 60. Okay, so for R1, that's going to equal 100. R2 is going to equal 200. RA, this is going to equal, we'll do the sum of the reciprocals formula. And we get 240, that's good. R5, that equals this one, that's good. And the total, that equals 60. Okay, so now we're ready to do our formulas. So this one equals the sum of the resistances. And we get 690, so that's good. The current equals the voltage divided by the resistance. So that equals 87 milli. That looks good. Now these currents are all the same. So that one equals this. Whoops. Try that again. All right, so those are all equal. And then we do the voltage. Voltage equals current times resistance. And for this, I'll just drag these down. So we get 8.7. So we got 8.7, 17.4, 20.9, and 13.0. So that was pretty close. Now we'll transfer things back up. So the resistance equals the resistance here. The current here equals the current here. The voltage for R1 equals the voltage here. The current equals that. That's good. I can drag these down for these two. So 17.4, that one's good. R5, that equals this. And I'll drag this one over. So now I've transferred back up R1, 2, and 5 from the bottom table. R3, we're going to transfer up the voltage. So that's 20.9 and 20.9. And then this voltage this current equals the voltage divided by the resistance. And so does this. And looks like I should probably space these out a little bit so that I get there we go. So I have 87 milliamps, 35 milliamps, 52 milliamps, 87. Those all look like they match up good. And then last we'll do the power equals voltage times current. And so we used Excel to do all of the power formulas. And so then I'll transfer these back over here. Okay, so let's go to here and we'll do the power formulas last. Maybe I'll do them in this color. So power equals voltage times current. So I took the voltage here times the current here, and I'm going to use Excel to give you the answers. So this one was 756 milli. This one is 1.51, 726 milli, 1.09, 1.1, excuse me, 1.13, and then 5.22. So I didn't really have room on the slide to put these answers in, so I grabbed the answers from Excel. And if I look at this Excel spreadsheet, it's voltage times current equals the power. Okay. All right, so that's the end of this one. So let's go to another example. All right, so let's make up a new problem. All right. right, so for this problem, what we'll do is we're going to have resistors here. Okay, so this is R1, R2, R3, R4, and R5. Let's say for this one we have an 80 volt supply. Let's make R1 500 ohms. We'll make R2 300 ohms, R3 400 ohms. We'll make this 700 and this 600. Okay, so here is our problem. We've got 5 resistors. Now for this one, let's start off. Oops. We're going to start off making our table. So let's make a table here. All right, and so we'll start off by putting in the known quantities. So we have voltage, current, resistance, and power. R1, R2, R3, R4, R5, and total. And then let's put in the known amount. So 500, 300, 400, 700, and 600. And then this is 80 volts. Okay. All right, so let's start off by putting in what to look at this. So, all right, what's in series, what's in parallel? So the first thing that we'll see is that these are in parallel. So that means that 4 and 5's voltage are the same. Okay, and then let's look here, and we'll notice that R1 we can't combine yet, so this is going to be kind of our first step here, which is that these two are in series. So that means that 2 and 3's current are going to be the same. And that's as far as we can get on this one. So what we're going to have to do is we're going to have to simplify this down. And for this one, we're going to do it in 3 steps. So we'll try to make enough room here. So we still have R1. And then when we simplify this down, we're going to have a resistor here, which is RA. And then R4 and 5 are going to get simplified down. And so they're going to be a resistor RB. And then we can put that in here, and so then this is still 80 volts. All right, so this is a 500 ohm resistor. So our first step here that we're going to do is find RA. So RA is going to equal R2 plus R3. So RA is going to equal 300 plus 400. So RA is 700 ohms. Then we'll find RB. RB is going to be the parallel combination of the 700 and the 600. So if we punch that into our calculators using the reciprocals formula, I get that RB is equal to 323 ohms. Okay, so now what we're going to do is we're going to make a table for this one, which will be our circuit 2 or circuit If we look here, what we're going to have is this circuit is A, so we'll have a table for circuit A. This circuit is going to be B, so we'll have a table for circuit B. And then we're going to have another circuit down here, which is C. And then we'll have another table for C. So there's a lot of steps on this one. All right, so let's fill out this table next. So we have voltage, current, resistance. So this would be R1, RA, RB, and total. So this would be 80. Now this is still a series parallel circuit, so we won't be able to directly solve for that circuit yet. So this is 500, 700, and 323. Now for this circuit, it's a series parallel circuit. So what we'll have to do is we'll have to get rid of the parallel part. So these two are in parallel. So that means that their voltage is the same for R1 and RA. Okay, and so now what we're going to do is we'll combine this, and I'm going to call this one RY, which is going to be the parallel combination of the R1 and RA. Then we'll put this voltage supply here, and that's still 80 volts. And this resistor here is RB, which is 323 ohms. So let's solve for RY. So RY is the parallel combination of the 500 and the 700. So we use the parallel formula. And that one is going to be 292 ohms. All right, so now we have finally a series circuit. So we'll make up another table here. And let's put in our quantities. So we have voltage, current, resistance, R1, that's actually RY, excuse me, and then RB. So we're looking at this circuit. And then total. So we have 80, 292, and 323. All right. Now for this circuit, the current is going to be the same. I got to be careful not to use the same colors. So for this one, the current is going to be the same. Okay. And then once we have, so if we kind of, let's go through this a little bit. So we go back up here. So R4 and R5 are in parallel. We combine that to RB. So that's going to be this voltage here, and that's going to be this voltage here. RY is the voltage for R1 and RA, so that's going to be the voltage here. And then once we have yeah, I think we're pretty close. We're getting close here. The other thing, let's look at this one. So the power supply and RB are in series, so that's going to be the same as this current. And all right, so let's start going through some of the math here. All right, so let's start off with the total resistance. So we have our total. So we're going to solve circuit C, then we're going to move up to circuit B, then to move up to circuit A. So our total is going to be 292 plus 323. So 292 plus 323. 3, and I get 615. So that's going to be 615 ohms. All right. Then I'm going to solve for the total current, I total, which is going to be 80 divided by 615. And that's going to be 130 milliamps. Darn it. All right, and then we can solve for Vy, which is going to be 130 milli times 292. So I'm going to take the voltage, is the current times the resistance here. So I have 130 milli times 292, and I'm going to round that up to 38. So this is 38 volts, 130 milli times 292. And then we have VB, which is going to be 130 milli times 323. And that's going to be 42. Okay, so let's transfer those up. So I have 42 there, and then I had 38, 38. Anything that's down here that's RB, I can transfer right up. So this would be 130 milli. This would be 130 milli. And then the 615 could transfer up as well. So now I'm back to this circuit. I found the voltage across these two resistors, so now I can find their currents. So this is going to be I1. And just a second here. Actually, let me back up just for 1 second. So 2 and 3 are in series. So once I have the current, that's going to be this current. So this is one of those things we've got to be a little careful of. This is the current here that's going to transfer up to here. Okay, so let's do that in this different color. So we'll have IA is going to equal 38 divided by 700. So let's do that one first. And that's going to be 54.3 milliamps. That's going to be hard to write in here. 54.3 milliamps. Let's just make it, oops. Let's try that again. So I'm just going to make this 54 milli. And then let's put that line back in there. Okay, so we got to be careful about this. We don't transfer up the voltage because it's not a parallel circuit. And so we use the orange here for the voltage to get the voltage across these two resistors. But we don't transfer that back up here because what we need from RA is the current because it's a series. If it's a parallel, which is usually what we do, then we transfer up the voltage. All right, so let's also do the last one, which is going to be I1, which is going to be 38 divided by 500. And that's going to be, darn it, 76 milliamps. All right, so then we can transfer these up, 76 milli, 38 for R1. What else do we have? The total, we could transfer those up. So this is 130 milli 615, and then here we'll transfer up the voltage 42, 42. All right, so now we have one last thing to do here, and that's going to be to find the unknowns. So for this one, so let's see here. So let's do, man, I'm really out of space. So V2 is going to equal 54 milli times 300. So that's going to be 16.2. V3 is going to be 54 milli times 400. And that's going to be 21.6. And then we'll do I4, which is 42 divided by 700. And that's going to be 60 milli. And then we'll do I5, which is going to be 42 divided by 600. And that's 70 milli. All right. So now if we look here, if we kind of go back to the beginning problem, if we look, the voltage across R1 was 38 volts. So this is 38 volts. The voltage across here is 16.2, and here is 21.6. So 16.2 plus 21.6 should equal 38. Okay, because those two have to add up. So let's try something here. Let's zoom in. Okay, so if we look here, this voltage across R2 plus the voltage across R3 has to equal R1. So 16.2 plus 21.6 needs to equal 38. Then if we look here, the 38, the voltage across R1, plus 42 should equal 80, and it does. And so that's good. All right, so let's try to make this up in Excel. Okay, so let's start here. We'll delete all of this, and we'll delete all of this. And so if we look here, we started off like this. So we have the total, this was 80, the resistance 500, 300, 400, 700, 600. Okay. Now, if we look at the next circuit, the cells that we have are R1, RA, RB, and then we have another one that we have we got RY and RB. All right, so let's go through this. So the first thing we'll do is we'll say that the total equals the total, and that this total equals the total. That's good. And all right, so first one for R1, that equals 500. RA, we said RA, that's going to equal R2 plus R3. So that's 700. And then RB, is going to equal, that's a parallel problem, so it's 1 divided by the 700 plus the inverse of the 600, and we get 323, so that matches up. And then we come down here, and our y, again we have a parallel problem, so that's going to equal 1 divided by 1 over 500 plus 1 over the 700. And for that one, I get 292. Now let's get rid of some of these decimal points here. Okay, and then RB, that equals RB. Okay, so we start off here, and it looks like our table matches up. Okay. All right, so now let's look at our math. So we were back to this circuit where we had a series circuit, so this equals the sum of these two. So I get 615. How does that match up? Yep, that's what we got there. Good. And then we'll say that the current equals the voltage divided by the resistance. This current is equal to this one because it's a series circuit. Voltage equals current times resistance. And we'll take this down, and we get 3842.80 and 3.301 milli, so that looks good. All right, this one equals the total. This one also equals the total. Now RB, that's the same, so we just transfer that whole thing up. Okay. Now this one, what we're looking for is, okay, what do we transfer up for RY? We need the voltage, so we'll take the voltage. So this would be 38, this would be there. And then now we'll solve for the current. The current equals the voltage divided by the resistance equals the voltage divided by the resistance. So I get 75.9 and 54.2. Okay, so that is good. All right, so now we'll go back up to this top one. So let's start off, we'll transfer up the total. Those should be the same. Okay, and then we'll do R1 because R1 is in that problem. All right, now RA, if we look at RA was the series combination of 2 and 3. So we need to take from RA the current. And from R4 and 5, we need to take the voltage from RB. Okay, so now we're back to this point, and now we can find the voltage here, which equals voltage for R2 equals the current times the resistance. R3 will be the same. And then R4 equals the voltage divided by the resistance. I'm sorry, I4 is the voltage divided by the resistance, and voltage divided by resistance, and that matches up. And then last we could do the power. The power equals the voltage times the current. And I'll drag those down. And so now I've calculated the power for each of the resistors. So let's transfer that back over to here. So on our final solution here, this is power, which equals voltage times current. And so from Excel, I got 2.88, 882 milli, 1.18, 2.53, 2.95, and 10.4. So those are my powers. And so I just took, if you look at this cell here, I'm taking the voltage times the current equals 2.88. So then, I just used Excel to extrapolate that. So if you look here, it looks like, according to Excel, we got the correct answers for this one. Okay, well that was the last problem that I'm planning on doing today, so thank you.